time for energetic.
Samina, mina, waka, waka, Samina, mina, sakalewa, anawa, Samina, mina, waka, waka, Samina, mina, sakalewa.
This time for energetic.
Chill. I think it's a beautiful representation of chemistry in its physical, in its like real sense of dimension. And hydrogen is a very fascinating element. And I hope today to be able to communicate to you just some of the love I have for it. And I think many of you have been developing it over the years. As Christina mentioned, we've been studying our Kangen water. I personally have been involved in the project for just over 8 years. I absolutely love everything that this company and this incredible technology and the science behind it stands for. And I think today we can just go a little bit deeper and build on what Rick has showed us, what Dr. Filzer introduced us to and expanded on, and just look at some science, some really incredible research that's been done specifically on hydrogen. So, without any longer ado, the power of hydrogen. We're going to understand the hydrogen, so we're going to understand what it is. I'm going to look at the current science and what does it mean for our health and physiological body. And then we're going to take a look at the hydrogen that can be produced through electrolytes-reduced water, or the hydrogen that's produced and dissolved in the water that we're drinking, and how that is superior to a lot of other forms. Hydrogen is easily the most abundant element in the universe, and it is said that some of the planets, even like Jupiter, are made mostly of hydrogen. The Earth, however, the majority of hydrogen on Earth and on our planet is concentrated in the water. Very little of it is found in the atmosphere, and just because of its affinity to, it's just so light and it's so small, there's an affinity to escape our atmosphere. And so most of it we'll find in water. And then we can definitely dissolve it or reduce it from there. When you look, I know many of you are familiar with the periodic table, and if you remember from biochemistry or chemistry 101, you will see that the hydrogen is on the very far top right. That is the smallest, the lightest element found in the universe. So isn't it incredible that we can actually work with this incredible element, that we have access to this incredible element, that we can actually capture it and bring it into our body? So a lot of it, a lot of the history, a lot of understanding of hydrogen started way long ago. In the beginning of the 1500s, the alchemist Paracelsus, I can never pronounce his name, he observed the bubbles of hydrogen. And then we had Robert Boyle that continued and observed it as well. But it's the Henry Cavendish who actually gets the credit of being able to collect hydrogen and review and understand the hydrogen gas and observe that it's actually flammable. So the name to the hydrogen was given by Antoine Lavoisier, and he called it water forming. Hydrogen was given to the name of this atom, for this molecule was given to it based on its principle of the fact that it's water forming. So it can be derived from water and it can reduce back into the water. What we're going to talk about today is going to be the diatomic or dihydrogen, or H2, or hydrogen gas. So we are going to look not at one single hydrogen molecule that you saw on the screen when you play the video, but you're going to take a look at them bound together. When it binds, when two hydrogens bind is when they become stable. Some see hydrogen as a clear fuel, and many of you have heard that hydrogen can be powering things. How many of you have heard of the hydrogen bomb or hydrogen fuel cell technology? We have technologies and the buses and the cars that can be and have been experimented on and have been driven and use the hydrogen technology. So it's an incredible power molecule. It's also used in multiple industries. It is used in chemistry, in food production, or dissociation, or work with that in processing. It can also be used in oil and gas refining. It can be used in many other industries.